Okay, we try to complete chapter 7 by today. We have already covered the design process. Today we look at process plan and process flow. So process plan, they are document. Process analysis, they are examination or assessment of your process, whether work or not, is it effective or not. Okay, so the rest you can read lah. I will just jump into the important parts. So Microsoft Visual, previously it was free to use. It can help you to organize your flow chart. But I think now Office Visual you need to pay already. Okay, you need to pay for this one. But it's a good tools because you have all the chart, all the shape that you need. It will be very helpful, especially when it come to your final year projects report and also presentation. Okay, so just but again, all this you can there is an online open source website also. Yeah. So these are have the steps lah. Have the steps. So you should already have your objective. What are your boundaries? Boundary means your scope lah. Your scope. So your unit, the unit of flow, and then type of the chart, process, and you try to validate the process whether correct or not. Okay. Now, for example, Big Mac. So sorry lah for those who you are start to have bulan berpuasa. So those you have puasa, sorry lah. So this one is assembly chart for Big Mac. So you can see here, Big Mac. There's a process of assembly the Big Mac. So you have three big layer. Layer 1 assembly, layer 2 assembly, and the complete assembly. Okay. So first layer you put from sesame until onion. You join them together, you get the first layer. Then in the middle part, you take from middle bun until pickles, you join to the second layer. You take the first layer, join second layer, and then you complete with the wiping to complete the third assembly. Okay. Another one is the plastic process. This will be a very simplified document. If you go to manufacturing plant, especially for the production floor, you will see the production manager will stick something on the station. Okay. So this is just an illustration of how plastic injection molding happen. Okay. So this one I won't play lah. Because when I upload into YouTube, it will come out copyright something. So okay, what is important is the flowchart. So the one that you see on the screen here is a very traditional flowchart. We rarely use nowadays, but in maybe early 40s, 50s, then you'll see this kind of chart. So it's just a plan of workflow. Use a symbolic square, arrow, inverted, triangular, just to explain the steps lah. So you can see here, operation, transport, inspect, delay, storage, and then the process. Okay. Okay. So this is a video about how they process the apples from farm to packaging department. So this one also you go and view lah when you have time. The YouTube link is below the slides there. You just copy and paste into a YouTube, or you can find apple from farm to table. Okay. What I want to talk about is this one also your homework. Go and read lah. Go and read. Early days, I do ask my student go and practice on how to draw this flow chart. but don't need lah. For this class, I think you are expert already, so don't need lah. Okay, this one you read. I just want to highlight that if you want to have a breakthrough in your process, it will take times. So you can see here on the left is your performance. When there's a breakthrough, your performance will jump at a certain time and it is in a straight line. This one you read. I want to focus on this chart. Okay, so this is a process innovation chart. It's important. So don't confuse this one with the design process chart. This is a process innovation chart. Don't draw the long one. So this one, you will from the top until the end. You have a directive. Then again, important is you should able to understand what is input, what is output. So for the first one, go for performance, process performance. You have 3 input: customer input, your strategy directive, and your data. When you fit in 3 input, you go to high level process map. High process map, you have a few input there. Then you go to detail, go to assessment, pilot studies, and then you assess whether you meet your goal or not. If yes, then you go to full scale implementation. This is a process chart, process innovation chart. Okay. The rest you read. Okay. Each one of it has their own chart there. So this one also you read lah. Principle for redesigning process. So got 10 principle for redesigning the process. This one proposed by this author, Omar. Okay, so this one also you read lah. Okay, if I let you know if this one come out, you just memorize lah. Okay, so this one also don't confuse this one. This is a principle. This one is a technique. So don't confuse with this table and this table. High level map and all this. So you have all the information there lah. Okay. Important is this chart. Important is this chart. Okay. Then once you have the chart process already, you go to decision. How you make decision. The another is technology decision. So technology decision involve you need to look at the impact, cost, speed, quality, flexibilities, and all this. Okay. So this is on the financial justification of technologies. A few factors that you often overlook. These are, I think, 4 or 5 points there. Purchase cost, operating cost, annual saving, revenue enhancement, replacement analysis. All these you read lah. Risk uncertainties, all these This will be the incoming future. So government now already in the direction of transforming all the factories, not all lah. At least they start with the 3,000 factory in Malaysia to convert traditional factory into smart factories. So I think by the time you graduates and if you go to those high-tech company, you will see robots moving around in the factory floor. Right. So some textbook use, if you use automation, some textbook use the word CIM, computer integrated manufacturing, or nowadays it was known as smart manufacturing. Okay. So this one is an old textbook material. It just explain what is e-manufacturing. E-manufacturing, which is nowadays also known as smart manufacturing. Now, when this book was established, there is no word like IoT. They don't know what is IoT yet. So they use the word e-manufacturing. So EM is e-manufacturing, consists of products, information, process, and manufacture. So you just look at the diagram, then you roughly know what is this EM. Then there are explanation on the CAD, the top yellow color, what are they? Group technologies. Nowadays in your program, in your degree program, you learn about CAD, CAD design. You learn about, in this module, you learn this one, CAD design, CAE, computer aided engineering. This one, you learn about ANSYS, you learn about, some of you learn about SolidWorks, CATIA, you do simulation, all these things. So this one, most of you learn about this one in your FYP and also EDP projects, right? Okay. So for this module, your projects, if you can, go and run some flow simulation on your models. You can use just key input into the ANSYS, run the flow simulation, show where's the vector flowing, what keep the glider, walk along glider flying. Okay. As long as you show me you use tools to do simulation, and then roughly the rough idea how the walk along glider can fly, what make it fly, is there a difference of pressure on top of the surface, why the board is important, and so on. So this one you verify with the tools. That's why 30% out of 100 was awarded for this module, because this module is project management plus product design. Okay, so in your I expect you present something about simulation results, about your models, some results from the software. Okay, you're not limited to any software you use, but as you can use CAD 365 or sorry 360, right? The AutoCAD software, free source, free open source software to verify or to argue about your product's performance. Okay. And most of the time, we ask you how you know some parameter, how you know your walk along glider can fly. What justified your design? Okay. So if you say I refer to YouTube, then you get a very low marks. You're actually copying someone's ideas without justifying the design. Okay. So if you're taking certificate level, you say I watch YouTube and then I just copy 100% and I present, then okay, certificate level, okay. But you are now taking degree level in the engineering discipline, then we expect you to add on more value into your projects. You look at how you analyze things. You look at why the design so and so, why your size of walk along is this. Like for example, 20 cm. Why 20 cm and not 30 cm? Why it's not 5 cm? Why the shape look like that? Why you choose that? You should able to justify your design using scientific explanation, not just I watch YouTube. YouTube's looks it can fly, then I test, oh, can fly. Then that is not degree level. That is certificate level or advanced diploma level. Okay. Another one is e-procurement. E-procurement, this one is getting more and more important. As you can see, our government start to, maybe your father or your family start doing business one, they start to worry about the e-invoice things. Okay, this e-procurement. Okay, the rest you learn you do expose to CNC in these universities. In other new program, they will expose your juniors to AGV, automated guided vehicles. They will learn how to program a robot, and they will know how to program a robotic arm and all these things. Nowadays, if you watch YouTube or any e-commerce platform, they will mention B2B. B2B, it means business to business. So it's between business entity to business entity, B2B. Your services is from business to business. All right. So B2C, business to consumer. You are handling consumer. All right. The rest, maybe your era, I'm not sure where you heard about intranet or not. Intranet. Intranet is internal, your company internal communication. The server is built internally, right? So intranet is internal system. You build a server, but your email cannot send out outside to other people. Or your process, your design, you come up with a design, your design cannot come out from the company. And then the last one is this one, AI, artificial intelligence. This one also getting more and more important. All right. You can try to go into AI if you have opportunity to learn what is AI, anything related to artificial intelligence, then you will be benefit for your career. Right. Future, this is easy to manufacture physical things. In future, we are looking for workforce with you know how to maintain the system, right? Maintain the system most of the time. You need to know what is AI, how to reprogram, how to find the problems in the system. If you are working at technical level, right? So maybe 5 years, 6 years, you are in the company, you move from a technical person to a management person. So different age or different level, different stage of your life, you will transform from technical to management or business-minded entity. Okay, so unless or your whole life is in the technical, you in the R&D department, then you also need some part of management as you grow older. Okay. Okay, this one is IPPDD, Integrated Product Process Design. This is a flowchart, a template for integrated product and process design. You can see stage 1, stage 2, stage 1, stage 2, stage 3, and stage 4. Okay. Okay. So have a look lah. This flowchart. Have a look. Okay, this slide is important because IPPDD is part of your scope, your learning scope. So it's important you know What is this integrated product process design? What is the benefit if you apply IPPDD, integrated process and product design? So all these are customer satisfaction, save costs, higher quality, minimize space handling and inventory, and the rest you read lah. Again, it still evolve within the triangular project success, cost, time, and customer performance, customer requirement. So one good idea from Edison that known for light bulbs. So actually, as I prepared the material for this module, actually Edison, he's not just think about light bulb, he think about the city power grid when he designed his light bulb. Okay. Then this one is more on the product development team. How you can make a product faster, the criteria you need for a product development team. So these are the points lah. These are points. You read and memorize lah if this kind of question come up. Most of the time, you need the member should be full time, because when they're full time, they give priority to your projects. Maximize the numbers means your resources, right? Your talent. Development of new product often balancing three factors. Speed, the speed of developing the products means the time lah, the time you need to develop the product. Time, cost, and performance again. Is still linked to the project success. Time, cost, and performance. So development speed, product cost, and performance. And quality lah. So this one is very direct, so I will go very fast. Okay, so product realization process means you make a product from ideas until you commercialize. There are 4 stages. 4 stages: identification, concept development, design, manufacture, and then you launch it. Okay. So this is from this table from this table. So you see the 4 box there. Stage 1, stage 2, stage 3, and stage 4. Okay. Don't confuse this table with a product design that you learn in the beginning of chapter 7. Don't confuse this one with the design flowchart. This is on the product realization process. The rest you read, there are lots of information there. What happened in each stage. So inside the slides. Okay, I don't want to make you guys boring. So you can read one, you go and read. Okay, their information. Although I spent lots of time preparing the slides, but I find it very boring if I read from the slides. Okay. Okay, the next one is more on psychology, more on managing a creative team. So creative people, if you are in the R&D department, most of the time you're looking for people that have ability, these 4 abilities: recognize problems, develop a solution, develop variety of approach to solve the problems, and develop a unique or original solution to a problems. Okay. So like your FYP lah. Your FYP, actually we try to train you to become creative. So you should able to recognize a problem in your FYP, final year project. They should have a problem you need to solve. Okay. Then you should come up with a solution, an alternative solution. Then you find the most unique solution in your case. Right? Same like your walk along glider projects. So you recognize that the problem, what is the problem in your projects? Customer give you a product to design. Your product is a walk along glider. All right. So you compare benchmark with the product outside there. There are lots of walk along glider design out there. Then you find the most interesting design that your team decided. Then you test it. You test it. Then you justify or you prove the concept by engineering tools. You use software, you CAD software, you draw it, then you run some simulation. You can run some structure analysis. Where's the weak point and all these things? Where are the weakest point that it can tear? What is the maximum load that it can handle, for example, right? Okay. This is more on teamwork lah, so it will be like a team building kind of talk. This one you read lah. Okay, this slide is important because we try to link with the project manager role. Project manager is a leader, so most of the time leader should have all these characteristics: communicate well, accept responsibilities, and know what customer want. Okay. Okay, this one you read. This is a 6 design stage. Again, objective, function, requirement, alternative, testing, and improving. This is more on psychology lah. I won't ask you on psychology. This is add-on information or reminder when you manage your projects, especially your walk along glider. So just I think you already passed this brainstorming process, right? So during brainstorming or you have a good discussion for new ideas, just focus, no criticize, no constraint, and then you improve on other people ideas. Okay. The next one will be product development process. Just now it's a process. Just now it's a process, design, all these things. Now we go into product. I'm going to product design. I will just give you some key and then the rest you read. Okay. So this slide is important. If the question asks you elaborate generic product development process, means we expect you to draw the flow chart below there. Okay, the flow chart below there. We start from planning. Then this square here is the decision point. Yes, no, success, not success, go where. So planning, concept, system level. You have a concept first, then you go into detail into system level. Once you done with the system level, you go into detail design. After you have detail design, only you go to the testing, then you go to the production. So this is the generic product development process. Okay. So how to read this diagram? This is just a pictorial diagram. It just tell you that when you're planning, you have all the data here, you do analysis, then you group them into, or you narrow down to one concept. Once you have one concept, then you expand again, you develop the system level design, you expand again. Once you expand, then you assembly them again. You narrow down again, become system level detail design. Detail design means you already finalized one design. Then you go to testing. One is testing, one is done. You certified, then you go to production. So this is an example of for the marketing. So you elaborate based on this generic product process. If it's marketing, application of marketing. So during planning, you look at the market opportunity and your segment you want to go in. Then concept development, you collect customer needs, benchmark your competitors. System level, you develop a plan for product options, and then you extend the families, like the soup, Campbell soup. Campbell soup start with 4, then you expand to 100 something, 125 products. Design, detailed design, developing a marketing plan. Then you test it with the market, you develop promotion, and then you field test it. You go and field test it, you launch the advertisement, and then you see what is the results. Okay. Okay. Example is Apple, how they market Apple. Just now is marketing. Application of this 6 process in engineering, in R&D department, designer. So you have all the things lah. Okay. So for example, the graphic card, NVIDIA graphic card. So you start from the left until the end. Manufacturing, also same. You just elaborate on the 6 concept there. So there are information for each process. You go and read. Okay, concept, system. Okay, as you can see here, I give you some pictorial there. Planning is getting an overview of what you want. So sometimes they refer this one as phrase 0. Phrase 0. Concept development is just developing the overview of what you want. It's just a concept. All right. Concept is a description of form, function, features of a product, and usually you will have a set of specification, analysis of competitive products, and economic justification of the products. So this is just an overview of what you want to do. For example, EV in the early days, they come up with a concept car, right? System level, you start to look into more detailed parts. For example, the EV car, you start to look at the size of the wheel, the seats, whether face front or facing front or facing back, and so on. Okay. System level, detailed design. Okay, detailed design will be on like the one you see on the screen here, technical drawing, all the dimension is there. You won't see detailed design in the concept development. Concept development just more on the function, shape, what actually the objective you want to do. But when it comes to detailed design, you actually fix the boundaries or they fix the parameters already. Okay. So all this material selection and all this. Testing refinement. This one is you go to if you're designing a sport cars, you test the car in the track and all this. Okay. This is Dyson prototypes. Dyson vacuum prototypes. So let's see if I have a chance to bring you guys to Dyson. It depends on times. Okay. So this also another Dyson products where they develop during the COVID time. They have speakers with air filters. This is their beta prototypes. Okay, then this is a GoPro products. They went through the same phases. All right. Okay. This one is a front end process. This one also you read. Okay, so when you go to work, you will heard about downstream and upstream. Downstream is towards the consumer already. Upstream is more on the decision, more on the before you launch to the customers or those at the higher level decision. Upstream and downstream. If you find a work that is in the upstream. If you work in a company that is in the upstream, not downstream. Downstream, you will be squeezed like hell, I tell you. Yeah. So the rest you read. Read. Okay, so these are the example of generic product concept, generic concept. So you can see these companies, when they design a headphone, they come up with more than 20 designs. Okay. So if your project related to product design, we expect to see a few sketches in the report. Then you go into detailed design. You'll come up with all these sketches. What is the function, and so on. Concept selection. There is a matrix on a concept selection. So in your report also, we expect you to have a matrix for selection. Why do you select that design? Okay, not simply anyhow. So you are smart enough to do reverse engineer. You already come up with 2 designs, so you should know how to do reverse engineer, right? So because you know the rubrics already there, you develop this matrix. Okay. Texting concept. Okay, so competitive benchmarking is important when you look at consumer products. Okay, if you join, for example, Dyson, you join those Johnson and Johnson, those big companies. If you join Geely, for example, you need to do analysis. All right. So for example, this one I extract from one of the journals. They do comparative benchmarking on all the models in the saloon car segment. So you have a brand on the left-hand side and all the parameters here. So I would expect you show this one in your project presentation also. The brand models what are the parameters you go and compare. Then the data, okay. Then you pick which one is the best. Okay. So these are the concept car. This is a Mercedes-Benz Vision EQ XX concept with the interior design. Haven't launched in the market, but they are at a concept stage. Okay. Another one is technology push products. What I mean by technology push products? Many successful technology push products involve basic materials or process technology. This may be because basic material and process are deployed in thousands of applications. One example that you see on the screen here is Goretrek. I hope I read it correctly. Goretrex. What they do, they manufacture sport products. What their strength is not in manufacturing sport products. Their strength technologies is in material, high-tech materials. They develop these kind of products that can repel water and also have all these things, protective, all these things, insulation and all this. These are their strength, their technologies. This company also have this stretchable or memory fiber that you see on the screen there. They publish these findings or papers in Science Direct. Okay. So these are the pre-existing products. Customized products. This one you read, This one you read. Okay, customized products is things that you already seen around you. Like for example, you start to see all the KFCs, all the fast food, they start to use kiosk system to make orders, and you can customize what you want. Like for example, McDonald's, you can add more veggies or no veggies, more sweet or less sweet, and so on. Okay. High risk, this one is you read risk management. Okay, so this table is important. It summarizes what we talked about in the previous slides. So you look at the first column, process type. There are a few process type, description, their features, and example. Okay. So this one is very popular. This table is very popular. Just take note on this table. Okay. So this is a summary of various genetic products development process. So I will just pick maybe 3 from here. You explain the description, their distinct features, and give an example. Okay, this can be half question, 12 marks out of 25. I pick 3, you answer, each one you give 4 marks. So each one you mention, 1 mark, 1 mark, 1 mark. 3 example means 4 point there, 12 point there. Okay, the rest you read, the rest you read. Okay, so these are the example of question for chapter 7. Okay.